We're swimming in numbers every single day. They're in the news, on our feeds. They tell us what to think, who to vote for, what to believe. But what if those numbers are leading you down the wrong path? Today, we're going to pull back the curtain and learn the language of data so you can spot the difference between a real fact and, well, a really clever deception. All right, let's kick things off with a statement that is, believe it or not, 100% true, but it just feels completely wrong. In cities that have more churches, there is also more crime.
Yeah, that sounds totally backward, doesn't it? So what is really going on here? Does this actually mean that churches are somehow causing crime?
The answer, of course, is a big no. But this is a perfect, and I mean perfect example of our first big idea. Numbers can absolutely lie. A statistic can be technically true, but without the right context, it can lead us to a conclusion that is completely false. So what's the real story? Well, it's a classic case of something called the third variable problem. This is where there's some hidden third factor that's actually causing both things to happen. In our case, that hidden variable is population. It's that simple. Bigger cities just have more people. And more people means you get more of everything. More churches, more schools, more coffee shops, and yeah, more crime. The two things aren't causing each other at all. See, this is the trap you can fall into when you just take numbers at face value. So how do we protect ourselves from this? How do we build up our BS detector? We learn to think like a statistician. And that's exactly what we're going to do right now. Thinking like a statistician really starts with one simple thing: learning to see what the data is actually telling you. Before you jump to any conclusions, you just have to paint a clear picture. And that's the whole job of what we call descriptive statistics, just summarizing what you've got in a way that actually makes sense. And what's a better way to learn this than with some candy, right? So imagine we just ripped open a single bag of M&Ms. We can just count them up by color and pop them into a little frequency table like this. It's a simple, raw summary of the facts. Okay, we've got 18 reds, but only 2 blues. Got it. Now, that table is useful, sure, but our brains are visual machines. The second we turn those numbers into a simple bar chart, bam, the story becomes crystal clear. You don't even have to read the numbers anymore. You can just see it. Red and brown are the big winners in our bag, and poor old blue is barely even in the race. And this brings us to a really core concept in all of statistics. Our one little bag of candy? That's just a sample. The population is all the M&Ms ever made everywhere. The manufacturer actually tells us what percentages they're shooting for. And if you compare our one little bag to their target, you can see our bag was actually kind of weird. Understanding this difference between your small sample and the massive population, that is everything. So the big question is, how can we use our small sample, our one bag of M&Ms, to make a smart, educated guess about the entire population? Well, that is the magic of what we call inferential statistics. So just to nail this down, because it's super important, the population is the whole shebang, like all the voters in a country. The sample is the small slice we actually get to look at, like the 1,000 people in a poll. But here's the catch. For this to work, your sample has to be representative. I mean, if you only poll people at a comic book convention about their favorite movie, you're going to get a pretty skewed view of what the entire country thinks. A bad sample gives you a bad guess. Simple as that. Now, this whole educated guess thing isn't just a hunch. There's a formal, powerful method for it called hypothesis testing. It sounds kind of scary, but the logic is actually pretty straightforward. First, you start by assuming nothing interesting is going on. That's your null hypothesis. Then you go collect your data. And here's the key part. You ask, okay, if my nothing's happening idea was true, what are the odds I'd see the exact data I just collected? If the answer is something like, whoa, that's incredibly unlikely, then you can confidently throw out your original assumption and say, you know what, something significant is probably happening here. Now, here's the best part. You don't need a PhD and a giant chalkboard to do this stuff anymore. The reality of modern statistics is that it's all about powerful software. And that brings us to the modern statistician's toolkit. Okay, just look at these names. The Kruskal-Wallis H-test, the Shapiro-Wilk test. I mean, come on. You absolutely do not need to know what any of these do. That's not the point. The point is this. For pretty much any question you could ever dream of asking, there is a specific, powerful statistical tool that was designed to answer it. You don't do the math by hand anymore. You let these tools do the heavy lifting to find the truth hidden in the data. So, we have these ideas, and we have these incredible tools. But let's get down to it. Why should you, personally, actually care about any of this?
Because, and I really mean this, understanding this stuff isn't just for a class. It's like gaining a superpower in the modern world. Because being statistically literate isn't some academic exercise. It's an essential skill for just navigating life today. It gives you the tools you need to react intelligently to the flood of information that's thrown at you every single day, from news headlines to marketing claims to political ads. And look, the stakes here are really, really high. As the source material for this whole explainer puts it so well, if you cannot distinguish good from faulty reasoning, then you are vulnerable to manipulation and to decisions that are not in your best interest. Thinking this way isn't just about being smart with numbers, it's about being in control. So, I'll leave you with a challenge. We've seen that numbers can be used to make things clear, or they can be used to confuse and mislead. The next time a big statistic flashes across your screen, what's the very first question you're going to ask yourself?